Hello everybody, happy Thursday. Today I wanted to do a quick little video just to do a quick little review over the exponent properties that we talked about on Monday and kind of why they work. You guys have a quiz next week over 6-1, 6-2, and 6-3, and that's going to happen on Thursday. So you got to understand why these properties work, not just how they work, but kind of why they work. So we're going to go over that real quick. So the first one we looked at, we had the product of powers. So if you remember, this one said for any two real numbers, okay, if they have the same base, so a's are the same, and they're both raised to two different powers, then all you have to do, remember we get bigger, so when we multiply, we're actually going to add those exponents, okay? So hopefully you have this written down. So I know some of the classes I went through this, but we'll just go over this again real quickly as to why this works. So an example that you could show for kind of explaining why this works is, let's say we have 2 raised to the third times 2 raised to the fourth. Well, you have the same base, you have the same number, so I'm just going to basically rewrite what this means. So you have 2 groups of 2 here, and you have 4 groups of 2 there. So if I write this out, it's 2 times 2. Okay, there's 2 raised to the second power, times 2 times 2 times 2 times 2. Because what it means to raise a number to a certain power is multiply that number by itself so many times. So then if I were to count these up, I have 2, 3, 4, 5, 6. So this is really 2 to the 6th power, which is why this rule works, because I have 2 raised to the 2 plus, not 3, I wrote 4. Okay, so 2 to the 4th, so we get the 2 to 6. So if I were to ask you why the power, or the product of the powers property works, you could just explain this to me, because you really just know how to lay it out. You know how to write out a number raised to another power. Okay, so then we wrote the power of a power property. Okay, there's a big difference here between these two. The first one, this one here, you have 2 numbers raised to 2 different powers. But here, you only have 1 number. So if I have a to the m, and I raise that to the n, you only have 1 number here. Okay, so you're taking that number, you're raising it to a power, but then you're taking that quantity and raising it again. So we're getting even bigger. Okay, so when I get even bigger, I'm actually going to multiply those exponents together. Okay, so again, if you need to explain this, it kind of makes a little bit more sense when we put it into numbers. So let's say I had, I don't know, if I have 3x, let's say, or no, here, let's do one number. So if I take 3 and I square it, and then I'm going to raise that to the 4th. Okay? Well, let's break this down as to what this means and why this rule works. So let's lay it out. Well, I technically have 4 3 squareds here. So I'm going to write that out. So I have 3 squared times 3 squared times 3 squared times 3 squared. Okay, so I have 4 of those. So now I have the same base, so I have the same real number being 3, and I have 4 of them. They're all being raised to the 2nd power. So I can either remember the previous rule with the product of powers and add those exponents, or I can literally lay this out. So I really have 3 times 3, 3 times 3. I'm going to do different colors to represent the 4 numbers that we have here. Okay, so then if you look at it, there's the 4 3 squareds. Well, how many 3's do you have? You have 1, 2, 3, 4, 5, 6, 7, 8. So I can really just rewrite this as 3 to the 8th. And that's how this property and why this property works, because you can lay it all out and use the first property within this next property, if that makes sense. So you're just basically laying this out and really understanding what it means to raise a real number to an exponent. Okay, so hopefully we can write that down. We can explain the why. Okay. All right, so we're still multiplying. Okay, so our last one, we have the power of a product. Power of a product. Well, product means to multiply. So what this is saying is I have two real numbers, A and B, and I'm multiplying those together, but then I'm raising that to a power. Okay, so I'm taking the answer to a multiplication problem and raising it to a certain power. So what this means, and what we wrote down yesterday, or on Monday, excuse me, was I can really kind of, in parentheses, distribute that exponent through. But you got to understand why that works. You can't just say you distribute that exponent through, because technically that's not what's happening. Okay, so this would be like if I had, oh, I don't know, 2x, and we're going to raise that to the fourth power. Let's make it easy here. So again, you're going to understand why this works. So think about what it means when you have 2x and I raise that to the fourth. Well, doesn't that mean I have 4 of those things? So I have 2x times 2x, and again, we're getting the colors just to represent how many we have, times 2x. Okay, so there's the 4, but then when you multiply, you know you can't multiply 2 times x and get a number. You can't combine those because they're unlike. They're not the same. So let's group together what my like terms are. So I have 2 times 2 times 2 times 2, then x times x times x times x. So you just kind of regroup. You're just writing it out. And now simplify. Well, what's 2 times 2 times 2 times 2? So we have 4 times 2, and then 8 times 2, so we get 16. Okay, and then x times x times x times x, well, if you think about it, those are all exponents of 1, right? So if I have 4 variables there, they're with no exponents, they're just 1, so if I add those exponents together, I get 16x to the 4th, okay? So that's why it kind of looks like you get to just kind of distribute that exponent through. It's because you can lay it all out here and use the very first property we learned about the product of powers. And you can add up those exponents to get your answer. Okay, so hopefully you can explain why this one works then. Okay, then we talked about the negative exponent. Oops. All right, so this one said, if you have a real number and you raise it to a negative power, all that you have to understand here is when you see an exponent, you've got a negative exponent, excuse me, you've got to get rid of that. That should be a red flag saying, hey, I cannot be here, so you've got to move me. So this just becomes 1 over a to the n. Now, the biggest thing you have to remember is when you move it, you're only moving the number or the variable that that exponent is attached to. Okay, and I'll show you what I mean in a minute. And the only thing that changes is it goes from the negative exponent to a positive exponent. Nothing else changes. Okay, you really have to understand that. And then there are some cases where you might see something like this, where you have 1 over x to the negative 2, something like this. Well, that negative cannot be down there either. So all this means is you're just going to move it up top. So this just simply becomes x squared. Okay, so hopefully you understand what to do with the negative case. So just a quick example of what I was talking about. You've got to move the stuff that it's only attached to. So let's say I have 2x to the 4th, y to the negative 2, all over, oh, I don't know, all over y. Okay, so right now I can divide and I can subtract. We haven't gotten to the quotient rule yet. So right now I'm only understanding that I have a negative and I'm only going to work with that. So all I have to remember to do is move this guy. Okay, so now this should become 2x to the fourth because that y is only attached to the negative 2. That negative 2 is not being distributed to anything else. So you simply are only moving that y squared. And then you still have y on the bottom. So then you just combine that to be 2x to the fourth all over y to the third. Okay? Sometimes the confusion comes from, like, if you have 2y to the negative 3, don't write this down because this is not correct. This is sometimes what I see where kids will take the 2 and move it down as well. Okay, and that's not correct because the negative 3 is only attached to the y. Okay, so try not to make that mistake. Okay. All right. Real quick before we go to the zero property, I want to talk about the quotient property. Okay, quotient means it is an answer to a division problem. Okay, so quotient property, we had a real number raised to a power divided by a real number raised to another power. Okay, so sometimes you guys think about canceling off. Well, when you divide, be careful when you say cancel. Okay, because you're not technically canceling it out, because whenever you have a number divided by itself that's not equal to 0, it doesn't cancel out, it doesn't go away, it becomes 1. Okay, so you got to remember that when we're dealing with the quotient property. You're always truly getting 1. Okay, we might not always write it, especially if we had, something like x squared plus x plus 1. Well, you don't have to write the ones in front of there because we just understand that there's a 1 in front of there. Okay, so be careful when you say stuff cancels out when you divide. Okay, so just a quick example about this guy of why it works. So let's just go something easy real quick. If I have 4 to the third divided by 4 to the second. Well, let's go with what we've done so far and write this out. So I have 4 times 4 times 4 on top, because I have 3 of them, and then on the bottom I have 4 times 4. Well, if you notice, you can kind of, quote unquote, cancel some terms out. If I take 4 divided by 4, that becomes 1. 4 divided by 4, that becomes 1. So I only have 2 in the bottom, so that means I can only take 2 out of there. So I'm really left with an answer of 4 times 1 times 1, but we don't have to write it out like that. Okay, we don't always have to put the ones there. So that's why we always just write 4. Okay, so this is why the quotient property works, because you're technically dividing the common terms and making it go down to 1. Okay, so this is the same thing as taking 4 to the 3 minus 2, which is just 4 to the first, which is just 4. Okay, so there's why the quotient property works. Okay, all right, and then one last one before we go back to the zero property is the power of the quotient. Okay, so you're taking some division problem, so A divided by B, whatever this may be, and you're raising it to a power. Okay, so what we got here is something that looks like you can, again, just distribute that exponent through. But again, we don't want to technically distribute it. That's not truly what's going on. Okay, and one little side note, remember, anytime you have a fraction, you never want the denominator to be 0. Okay, always keep that in mind. We don't want it undefined. Okay, so a quick example. Let's just take a real easy one. So 2 divided by 3, I have that quotient, and I'm going to cube it. Okay, well again, Anytime I raise something to a power, it means to multiply that number how many ever times the exponent tells me to. So here I have 3. So 2/3 times 2/3 times 2/3. So there are my 3. Okay, so all I got to do here when I multiply fractions, some of us got confused the other day. When you multiply fractions, you multiply straight across. You don't cross multiply. That's only when you have an equal sign. Okay, so this just becomes 2 times 2 times 2, which is 4 times 2, so it's 8. And then 3 times 3, which is 9. 9 times 3, which is 27. Okay, and anytime you have a fraction, try to simplify it if you can. Here I can't, so I'm just going to leave it. Okay, so if I lay this all out as to why this works, it just makes sense because you're simply multiplying all these numbers together. Okay, so I can really, truly write 8 as 2 to the 3rd and 27 as 3 to the 3rd. And I can simply plug that into my calculator. You don't necessarily have to show all of these steps as to why for every single problem. You can jump down to what our formulas or our properties tell us, but there might be a question on, say, a quiz or a test that has you explain why one of these properties works. And as long as you can understand and show me that you just have to simply lay everything out and show me why the multiplication and the division works, then you're good to go. You're explaining why. And that hopefully makes a little sense. Okay? All right, the last one is the zero property. So the zero exponent. All right, if you understand the division, then this one should make sense. Okay, so if you understand when we have a quotient, you're not technically canceling things out. It doesn't go away, but it goes down to 1. You'll understand why anything raised to the 0 power is 1. Okay, so we wrote this down on Monday. A to the 0 is always equal to 1. All right, so I'll just give you a little example here. So first off, side note, and this hopefully is common sense, and you're going to see why I'm talking about this in just a second, but anytime you have a fraction, so you have some number, and it's divided by itself, what does that always equal? Okay, well, if it's the same number on top and bottom, it's always equal to 1. Okay, so if I have, I don't know, x to the 4th divided by x to the 4th, okay? If you look at that, that is the same number on top and on bottom. So truly, I could think about it right off the bat as same number, so it's equal to 1. But I got to understand that a little bit better. Okay, so what this means is to write it out. So I have x times x times x times x. We've been doing that all day long. Okay, just writing out what it means. So then the bottom is the exact same thing, right? Okay, so now if I group these kind of together with trying to cancel off the same amount from the top and bottom, notice something that happens. These go down to 1. These go down to 1. These go down to 1. And that goes down to 1 as well. So truly what I have here is 1 times 1 times 1 times 1. I don't have 0. Okay? I've never, if I had something like 2 divided by 2, I have never written 0. Okay? Because there's still a number that's there. 2 divided by 2 is always equal to 1. Same thing goes for this quotient rule. Okay? So if I come back over here, x to the 4th divided by x to the 4th, the other thing is, think back to the quotient rule. If you have the same base, all you have to do is take x to the 4 minus 4. Well, guess what? That's x to the 0 power. And what did we just show that it equals? Well, it equals 1 because we can divide the same number from top and bottom. We can divide that down to 1. So that is why any number raised to the 0 power is always going to be equal to 1. Because truly what we have, yeah, it makes sense because we have the exponent on top minus the same exponent on bottom to give us 0. But if we truly write it out, The reason why this works is because we always have this happening. We have the same number on top and bottom, so it quote unquote cancels down to 1. Okay, so hopefully that makes a little bit of sense. So we can certainly go over any questions on Tuesday when we get back over any of the properties and kind of why they work. And I think we looked at those reasons a little bit on Monday for all the classes. So I just wanted to double check that we're all on the same page, just to kind of give you a little hint for next Thursday on the quiz. Okay, so today your homework is that 6.1 worksheet. So there's 2 sides, front and back. The answer key is here, so hopefully you can get through this the majority of the class time. You don't have a whole lot of homework over the 4-day weekend. So if you have any questions, feel free to email me. Otherwise, we'll definitely touch base again on Tuesday. Okay? Have a great long weekend. We'll see you on Tuesday.